Here's another example where the numerator is linear and the denominator is a quadratic. First, let's try to simplify. I can't simplify the top. Can I simplify the bottom? I would need two numbers that added to give me -1 and multiplied to give me -12. So that must be 4 and 3. And I need to add to negatives, so it's -4. Okay, so that's 3x minus 4 over x minus 4, x plus 3. X minus 4, x plus 3. There's nothing I can simplify there. Okay, remind myself what I'm doing. Intercepts. For the y-intercept, let x be 0. So I've got -4 over -12. That's 1/3. For the x-intercept, I have to let y be 0. That's the value of my function. Well, if y is 0, then it's actually only the top of the fraction I really care about. It's the top of the fraction being 0 that I want. 0 is 3x minus 4. X is going to be 4/3. Okay, discontinuities. My graph is discontinuous where the bottom of my fraction is 0. Discontinuous where the bottom of the fraction, x minus 4, x plus 3, is 0. Well, that means x is 4 or -3. They are vertical asymptotes. What about extremities next? Well, as x approaches plus or minus infinity, what did we learn? We said y is a over cx, 3 over x, which gives me a hint as to what's going on. Let me just go approaches instead of equals. Y approaches this, which is approaching 0. So as x is positive, infinity, as x gets to very large positive, y is going to be positive above the axis. When x approaches negative infinity, x gets a very large negative, this number will be negative, so y will be below the axis. But this also gives me the horizontal asymptote. Couldn't spell it right. Okay. Now, does my graph actually cross that asymptote? And yes, it does. I've already answered that question. It actually crosses the asymptote, y equals 0, when x is 4/3. Graph crosses y equals 0 at 4/3. I already answered that question. I'm probably going to want to find a couple more special points. Like the previous one, there won't be any stationary points in this example, but I'm going to want to substitute a couple of points to find the shape of the hyperbola at each end. So let's try drawing a graph. The y-intercept is 1/3, 0, 1/3. The x-intercept is 4/3. That's just past 1 here. 4/3, 0. Trying to get out of the way of where the graph's about to go. Vertical asymptotes at x equals 4 and -3. What else do I know? There's a horizontal asymptote at y equals 0. What's my graph doing around those asymptotes? Well, it's crossing here. It doesn't cross this asymptote anywhere else. So it must be going up here and down there. In fact, I can draw that straight away because I know what it's doing. It doesn't have much other choice. What's going on over this side? We decided as x is positive and large, then y is positive. So it must be going up to here. As y is large but negative, as x is large but negative, y is going to a negative. So it's coming here. So it must go down here. Just how tight are those graphs? I don't know yet. Let's do some calculations. Let's try -5 and +6. At x is -5, y is 3 times -5 minus 4 over 5 squared minus -5 minus 12. Let's do that carefully. -15 take 4 over 25 plus 5 take 12. 15 and 4 is 19. 30 take 12 is 18. That's just greater than 1. And as x is 6, y is equal to 3 times 6 take 4 over 6 squared minus 6 minus 12. So 18 take 4 over 36 take 18. That's 14 over 18. If you prefer, it's 7 over 9. I did something very wrong. What did I do wrong? Ah, yes. This one is negative. I missed the negative sign. Okay, let's put those points on the graph. X is -5, y is negative just over 1. That's -5, -19 on 18. As x is 6, y is 7/9. It's not quite as high as 1. Again, a very tight curve. Here, that's 6, 7 on 9. So this one comes all the way down, curves just a little bit, and then goes out. And this one comes out here, goes through that point there, and goes down. It might be worth just highlighting it's that point there and that point there. And there is my graph of 3x minus 4 over x squared minus x minus 12.